Okay. Hello, professors. I'm going to be presenting to you the technology that I use for my final project. It's going to be using solar power on the PE facility. The solar panels that we're going to be using on the gym is going to be installed by Renusol. They're going to make sure that all of the permits, the licensing, and all that needed to correctly install is going to be taken care of. And so the cost of all of that is going to be $376,750. So to calculate how much money is going to be saved when you use it during the operating period of August 1st to April 30th, it's going to be 3 of those months are in the summer, and then 6 of those months are going to be during the winter. So what we have right here is just the demand charges, so not including time of use, none of that just yet. But I have broken down with summer, peak hours, summer regular and solar, and then winter with partial peak winter and solar, because there's no peak charges for the demand period during the winter hours. So the first one, just regular 300 kilowatt load, which is what the facility is going to run at, and just run it through. It sees that it's $17,136, and then when you implement the solar power, it takes off that 250 kilowatts of the 300, so you're just left with 50 kilowatts running during the peak hour, which gets to 2,856. And then the same thing is done during the partial peak for the winter and the regular facility, and then the 50 kilowatt facility. You can see it's $432 without the solar, and then $72 with the solar. Okay, so now we're going to do the time of use charges. So to do that, you take the regular kilowatts of the load times the hours during the peak time, which in this case is 6. The amount of days during the summer months that the peak time is actually applied is 64 days, and then this right here is the charge per kilowatt hour. So with the 300 kilowatt load, it is 18,700, and then with the solar power being used just with 50 kilowatts left during the peak time, it's 3,116. The same applies for the winter time, because the winter month time frame is longer than the summer one. The days are going to be more, which is 124 days, and the 13 hours is the time for the partial peak during the winter. The reason the days aren't exactly lined up with 90 days for 3 months or 180 for the winter is because the peak time doesn't count weekends or holidays during that time. So it subtracts those days from the peak days, which is why you're left with these numbers. So partial peak for winter without the solar is about 49,000, and then with the solar it is about 3,788. Okay, so the total energy charges with the demand and time of use for without solar is 113,158, and then with using the solar is 94,214.80 cents. The savings when you use both of those would be 18,999.10 cents. If you extrapolate that for the year, it'd be $48,807.80. And then you would just divide the total cost by this number done here, and it would pay it off in 7 years and 9 months. In order to additionally help with saving money, you could change the lights that are in the facility. They use fluorescent. In order to make it a little better, you could use LEDs, which are $9 a light, as opposed to the $23 per fluorescent light that is being used currently. The LED lights are also cheaper, brighter, and they last 2.5 times longer, which is when you're switching out with 40 lights, it saves $560 per change out. So you can save that money because you have to change them out. Another advantage would be using a motion sensor in the gym, because the lights on the basketball court and they're always on. So using a motion sensor with the lights that are rated at 0.250 kilowatts per hour during the peak time for the summer times the 40 lights would save you $1.63 per hour if you just turn them off for just 1 hour during the peak time per day. So that's the project, and hope you liked it. Thank you.